Okay, let's go ahead and finish up the last bit of information, and then we'll do any questions you have. I don't know if I'm spelling this right, but here we go.
That's French, right?
I think so. We. It's all the French, yeah. Le Chandelier principle. All right, so Le Chateleir principle states that if a system is in equilibrium and it experiences a change, it's gonna kind of counter. It's gonna change so that it's gonna shift so that it counteracts that change. So, system in equilibrium that undergoes change will shift to counteract the change. Undergoes, so that means if it changes. If a reaction in equilibrium changes, and we'll explain what this means. Counteract, so go against. So if we have nitrogen gas with hydrogen gas, and we get ammonia gas. Whoops, I should write that this is an equilibrium. If I add more nitrogen gas, what direction is that going to push the reaction? In the forward and the reverse direction? Forward. If there's more of this, then it's going to react with this, right? More often. Therefore pushing it this way. So we add it to the left and it pushed it to the right. What if we add more ammonia? It's going to push it to the left. Does that make sense?
In three,
What?
this after plus ammonia,
Say that again.
ammonia, which way you add that pressure?
So here's ammonia. If we add more ammonia to our, so this is all in the same container, right? It all happens together. So if we have this reaction going, we just dump some more ammonia in there, ammonia gas, it's going to push it this way.
Go back to
Because now we have more ammonia that can break down. You with me? Questions on that? So that's with concentration. So if we add more of any substance, it's going to push it the other way. Does that make sense to everybody? Okay.
concentration.
What if we have a pressure change? Again, this is all in one container. So you add pressure somehow, right? By decreasing the volume or increasing whatever. So we add pressure. What's going to happen? Pressure deals with what type of molecules? gas, right? So it's like adding more gas. If we increase the pressure, these gas molecules are going to run into each other more often, yeah? So what way would it push this reaction? There's gas everywhere. Probably to the right because there's more gas on the left, right? There's gas on the left and gas on the right. But there's two components with gas on the left, so it's going to push it to the right. You're right. Does that make sense? So it's going to push it this way. For this example, is it always going to push it to the right? No. It's going to increase. It's kind of like increasing the concentration of the gas particles. Yeah.
Well, it kind of goes with the collision theory, right?
Yeah,
Where it's
exactly.
Like increasing the
Yep.
chances that it'll collide.
That's right, exactly. And in fact, this is all according to the collision theory. Yep. Does that make sense so far? What else can we do to change our system?
Would that with pressure happen going left too? Like if you add more pressure somehow?
But we're adding it to the whole system. So would it increase the rate going to the left? Yeah, it would. But where would it increase the most? Probably going to the right because there's more gas particles on the left side. Does that make sense?
Yeah.
So if we have, let's say we have another, let's do change in temperature. So if we have hydrogen gas with iodine gas, and it gives us, HI as a gas. And this is, well, if I have plus 7 kilojoules, what kind of reaction is this? Exo or endothermic?
What is ammonia? Is iodine.
This is exothermic because we're getting heat as a product. We're releasing it. Good? So what direction would the reaction go if we increased the heat?
Far backward.
Here's the heat over here. If we increase it, it's going to go this way. Because if you flip this around, what kind of reaction is it now? Endothermic, right? So it's exothermic going this way and endothermic going this way. So if we add temperature, increase the heat, it's going to push it toward the endothermic direction. Does that make sense? What if we remove heat?
Everything come down back.
It's going to go toward the right. Because you need heat for it to go to the left. It releases heat. So if you don't have a lot of heat, it's going to push it the other way. Questions on that? Yeah.
So you said so this reaction is exothermic, right?
Well, in the forward directions, it's exothermic. In the reverse directions, it's endothermic. Does that make sense? Because if we wrote this backwards, now the heat is on the reactant side. Now it has to absorb it to go that way.
So the endothermic is this way, and exothermic is that way.
Yes. Uh-huh. Are we good with Le Chatelier's principle here? Yeah.
Yeah, sometimes I've seen these reactions written with kilojoules as minus this many kilojoules if it's being released. So is that just a different?
Good. If delta H, yep, that's just a different way to write it. We could also write this as H2 plus I2 2HI, where delta H is -7 kilojoules. Why negative? Because it loses it, it releases it. So negative delta H is exothermic. Since it's on the product side, it's also exothermic.
This delta is always meaning heat.
Delta H means a change in heat.
Yeah, but the sign is also.
The delta means a change in. Not always energy. So this triangle means a change in. We can change in time, we can change in speed, we can change in whatever. Temperature. It doesn't have to be heat. When it's delta H, then it's a change in heat.
You will show us.
Not today. Besides, you already seen those. Those are for my next class. Are we good here? What if we add a catalyst? And you need to know this. So if we add a catalyst, what does a catalyst do? But how does it speed up?
By lowering the activation.
Lowering the activation energy, yeah. So if we remember our graphs, so here's our graph. If we add a catalyst, it lowers that activation, and that was kind of a bad drawing. Lowers that activation energy. It was this high, and now it's this high, right? And remember, if that activation energy is low, it goes quicker, right? But when we add a catalyst to an equilibrium system, it does not change. It doesn't shift it one way or the other. Does not shift. So a reaction will change the rate, but it does not shift the reaction.
Oh, it does not shift.
So it can help it reach equilibrium, but once it's in equilibrium, it will not shift it. It won't do anything. Any questions on the Chateleir's principle? Okay, on the back side, on section 9, does anybody need one of these?
I need-
There's a few situations. Let me just pull this up and we can just do these together. All right, so it asks us to determine which way the reaction shifts for the given addition. So we add hydrogen gas. Which way is it going to go? Toward the reactants or toward the products? Toward the reactants, right? It's going to shift it this way. We add more of that, it's going to shift it to the other side. Straightforward?
Because you have two hydrogen.
If we add products, it's going to shift it to the reactants. If we add reactants, it's going to shift it toward the products. Why does it shift? So that it remains in equilibrium. We good? What if we increase the pressure? Let's do a different color. Shift to the right, to the left. There's more gas on the product side, so it's going to shift it to the reactant side. Make sense?
All the way to the carbon.
Well, it's going to shift it to the reactant side. It's going to make more carbon and water in this case. It won't just make more carbon only, it makes more reactants. And yeah, if we increase the pressure, it's also going to increase how often these things collide with the carbons, but there's a little bit more since there's more gas on this side. So in the end, altogether, it's going to push it to the left. Yeah,
So if you increase pressure, it'll move away from whichever side has more gas?
mm-hmm.
Okay.
Does it make sense why?
Kinda, not really.
So pressure is dealing with gases only, because you can't pressurize liquid and you can't pressurize solids, right? So if we increase the pressure, these gas particles are going to be running into each other more often. And the more often they run into each other, then it's going to react more often, right? Therefore, push it in the opposite direction.
That makes sense.
Good? Thanks for asking. Anything else? Okay, what about the addition of a catalyst? No change, right? Can you guys see that okay? All right. Addition of sodium chloride. This one's tricky. You're going to have to really think about this one. It's not just, we're not just adding salt. What are we adding? Salt water. It's aqueous. So what are we really adding? Do you guys know what I'm adding when I put salt water in something? I'm adding sodium ions and chloride ions. So use that to guide your thinking. Does it help the reaction if I add sodium ions to it? No, there's no sodium in this reaction. So what I'm really adding is the chloride ions. So which way is it going to push it? Toward the product or toward the reactants? See how this is aqueous? That means there's chloride ions. If we write the complete ionic equation, we're just adding more chloride ions. Good, so it's going to push it this way. Yeah.
So, even though there is silver chloride on the right, it's not aqueous.
Yep, this is not aqueous, so that's not a chloride ion.
It's not.
Yep. And it'll just make more of that. Will it make more of this? No, it won't. Right, because that's not even, it's still dissociated. Good? And last one, if we add heat, what way is it going to push it? Toward the product or toward the reactants?
To the products.
Why? Because the heat is in the product side, just like everything else. Whatever we're adding, we're just adding more of this, so it's going to push it the other way. We're adding more of this, so it's going to push it the other way. Catalyst doesn't change equilibrium. We're adding more gases, so it's going to push it the other way. And we added more hydrogen, so it's going to push it the other way. That makes sense to everybody? Okay, that's it.
So, our list of increasing rate of reaction things, we also had stir. Is that applicable at all under the, whatever his name is?
Le Chatelier's principle?
The
Yeah. If you stir it, what's it gonna do? Both of them, right? Because they're all together.
So how would we, like?
It will not affect, it will not affect it.
Okay.
Yep.
If it's not shifting, it's just.
So the only things that will is concentration, pressure, temperature. Yep, good question. Anything else on that? Great questions. Okay, there will be one of those on the exam. There, I think. We'll find out. All right, that's it for this unit. Have a great day. No, I was kidding. No, if yeah.
Are we gonna go over section 5 on this worksheet?
Section 5. We can probably go over some of them. Let's see. The reason I didn't go over that, well, we kind of went over it, but for some of them, you kind of have to know what's going on. You have to know what the temperature, because the temperature will change it, right? So the equation is delta G equals delta H minus temperature. Remember, the temperature has to be measured in Kelvin, because if you have a negative degrees in there, that's going to throw it off, okay? So we need the absolute temperature. All right, so if we have, says iron rusting at 30 degrees Celsius. Well, does anybody know if this is an exothermic or endothermic reaction? Do you know that, or are you guessing? So you'd have to know more to be able to do these, right? Unless say, okay, we don't know that. Okay, is it going toward more disorder or less disorder? Less disorder. Okay, so we have a negative delta S. We don't know what that is. Do we know if it's spontaneous? Does anybody know that?
I'm gonna say yes.
Okay. You either do or you don't know it. Is that right? So, what I should have done on this one, in fact, I should change this, is added whether it was delta H was exo or endothermic, right? Because if we do know this is positive, can you tell me if it's positive delta G or negative delta G? What is it? It's positive. If these are opposites, then these two are going to be the same. Okay, that's the easy process. But what if it was negative? Now it depends on what? The temperature. So is 30 degrees going to make it spontaneous or is it non-spontaneous? That's just barely above room temperature. Maybe it's spontaneous because things still rust at room temperature, right? So we can maybe come up with a good guess on this. But it would be better if we knew, okay, what temperature does it rust? And as a whole, we don't know that, right? Does that make sense to everybody? So I'm not going to give you one like that. But that's kind of how you'd be thinking about this. If we do the next one, combustion of ethanol You guys have this in front of you, right? Okay. So combustion of ethanol, this time it doesn't tell us the temperature. So let's see. What do you think? Is it exothermic or endothermic? What kind of reaction is this? Exothermic, because it's the combustion reaction, right? So that means it's negative right here. Does it go toward more order or more disorder?
Disorder.
More disorder, so it's positive, right? Since they're opposite, what's delta G? Negative. So that one, we can kind of think our way through it. Or we should be able to.
Because one big molecule cut off to the two.
So are you asking why it's more more disorder?
No, I just says it's a big molecule and big after the heat it become two more
Meaning like,
molecules.
Well, it was started with 2 and ended with 2. So
Started with two and ended with two.
yeah,
But even in with two is different.
they are different. That's a chemical reaction. That's always what
It's
happens.
negative. The heat made it negative.
No, the reason it's negative, the reason it's exothermic is because this is a combustion reaction. And in all combustion reaction, we have some carbon-hydrogen compound with oxygen, gives us carbon dioxide and water. So if we have a combustion reaction, it's going to be exothermic. We burn gas, we burn propane, we burn wood, all these things. It's going to give off heat. Right? So this is a little bit more understandable to our everyday experiences, maybe. Okay? Yeah. Does that make sense to everybody? Okay. And the next one we have H2O as a liquid going to H2O as a solid. And this is at 5 degrees Celsius. Okay. So is this exothermic or endothermic?
Exothermic.
We're releasing heat to get it to become solid, right? So this is exothermic. All right. Is it more, does it go toward more order or more disorder or less disorder?
Less disorder.
Less disorder, so it's a negative delta S, right? So, so what's delta G? They're the same this time, so it depends on what? Temperature. Can we do it with this one? Is this going to be spontaneous or non-spontaneous? Non-spontaneous, because ice melts at 0 degrees Celsius. If it was flipped the other way around, it'd be spontaneous, right? So this is non-spontaneous, therefore it's positive. You with me?
But it's the delta H is also.
But so this is one thing that everybody probably should know, is that water freezes or melts at 0 degrees Celsius. Okay? And the last one,
Is it the delta H is negative
because it goes from a,
heat
yeah, you have to release that heat
that's
to get ice. Yep. If you dissolve ammonium nitrate in water, it makes it an instant cold pack.
dissolved.
So what kind of reaction is this? Endo or exothermic? Exothermic.
Negative.
We don't have a formula here, so it's going to be hard to know what delta S is, right? What do you think? If it goes to a cold pack, it's going to make things more solid or more liquid? More solid, so what do you think? More order or less disorder, right? Less disorder, so negative again.
Is it
So is it spontaneous or non-spontaneous? It's an instant cold pack. How do these work? You crush it all together, get the reaction go, and then what? It'll get cold. It'll stay cold, right? You don't have to keep doing this, right? Is that right?
So we just want to do this.
But again, if you've never used a cold pack, would you know that? But it kind of tells us instant, so that means, in this case, it's negative.
All of them
They are in this case, yeah. Are we good there? Did that help?
what about the first one?
So, but on that iron rusting, did you know 30 degrees was hotter than room temperature?
No.
Then you'd have to convert it to Fahrenheit. Ooh, I didn't show you how to do that. Because that's why we have smartphones, right? All right, we good? Any other questions? So if you went over that study guide, that would be a good source to come up with questions, because that's basically the test, right? Even if your question is, what is number 5 even talking about, for example? Oh, number 5? Oh. Okay. All right, number 5 on the review, or on the study guide, says, know why an atom is oxidized and why an atom is reduced. So what does oxidized mean? Oxidized means loss of electrons. It loses electrons, right? Or, in other words, its oxidation number what? Goes up. Okay, that might be an easier way to think about it, because reduction is what? A reduction in oxidation state, or oxidation number, or lowering in charge, right? So if it lowers in charge, that means it gained electrons. Or you can think of oil rig. Or Leo the lion says grr. I can explain it if you want. I'll try to anyway. And then it says until which is oxidized and which is reduced. So should we do an example? Okay. So let's do, how do we know, I mean, this doesn't really have examples in here. So if we're studying with this, how do we know what to do? Well, oxidation reduction reaction, what type of reaction is that? Is it going to be a double replacement reaction? No, so anything that's not. So ask AI, say, give me an example of an oxidation reduction reaction, right? Have AI help you with this. I got to be careful when I say this to high school students. They'll have AI do it for them, and then they won't get any good out of it. But yeah, have AI help you study. So we have, let's do C3H8 plus O2 gives us CO2 and H2O. Good enough? This is a combustion reaction. It's not a double replacement, so oxidation reduction. All right, so we got to determine which one is oxidized, which one is reduced. So you got to determine the oxidation number. So let's start with the first compound. It doesn't matter where you start. I start from left and go right. So This is a covalent compound. So what's the where do we start? Carbon or hydrogen? Do y'all remember the order? Okay, so hydrogen, if for a covalent compound, you check hydrogen first. You got to go in this order. And hydrogen's oxidation number is +1 because it's in group 1, right? It's kind of like its charge. And then the next one is fluorine. And what's fluorine's oxidation number? So if there's no hydrogen, then we see, does it have fluorine? What's fluorine's oxidation number? -1 because it's in group 7. It's going to gain electron, right? And y'all with me? And then after that, we check what? What's the next element? Oxygen. And its oxidation number is? Is oxygen's oxidation number always -2? It's not. In the case of hydrogen peroxide, it wasn't, right? Okay, so this is why we got to check. And then what's next? Chlorine, bromine, and iodine in that order. And their oxidation numbers is -1. Is that they're in group 7. So you got to follow this order. Now, you only have to check one of them, most cases. There might be some cases that you'll have to check more than one. So if we're doing oxidation numbers, we're going to do hydrogen first because, well, that's the first one. And its oxidation number is +1. How many are there? 8 of them, so that's +8 plus 3 there's 3 carbons times whatever it is for carbon. What does that have to equal? 0. Why 0? Because it's a neutral compound. Its charge, the total charge is 0. If it was in a polyatomic ion, the total charge might be a -1 or a -3 or a +1 or whatever, right? And so from here, you just do a little bit of algebra. You subtract 8. And we got 3x equals -8. We divide 3, and we get -8/3. Is that okay? Sure is. It's just an oxidation number. Doesn't tell us how many atoms there are, just an oxidation number. That's fine. Okay? All right, what's the oxidation number for oxygen in O2? 0, because it's all alone, right? Any element all by itself has an oxidation number of 0. Okay, now let's go to carbon dioxide. What do we deal with first, carbon or oxygen? Oxygen, because carbon's not even on this list. And its oxidation number is? -2. There's 2 of them. That's -4. So what does carbon have to be? +4, because it's a neutral compound. Is this making sense? Okay. Go to water. First one we check is hydrogen. Now do we check oxygen? No, you just check one. And then you figure it out. If we do this, oxygen is -2 in this case, but it won't always do that. So you have to just check it mathematically, yeah.
Why is oxygen not -2 and hydrogen peroxide?
I'll show you. Because if this is +1, +1 times 2 is +2, plus 2 times x is equal to 0, minus 2, divide 2, you get -1. That's why.
Why -1? Because
I mean, that's, mathematically, that's why. I mean, if you ask, yeah, but why? Because that's the way it is.
But I have a question.
I don't know, did I answer your question? Okay. And Mariana? Then,
Why does the H2 stay as +1 and not +2?
its oxidation number is +1, but there are 2 of them, so it's +2, plus whatever it is for oxygen has to equal 0.
No, but oxygen.
And that tells us oxygen is -2.
But oxygen has.
Did that answer your question?
But if you could
Now, this is the process we use to figure out the oxidation number for oxygen, for the other element. So hydrogen will always be +1. Okay? Just like when we did over here, it's +1, but there's 8 of them. Right? Same thing. Did that help? Okay, Amon, what was your question?
When it's hydrogen to hydrogen, it's supposed to be positive too, that's correct, but it's supposed to be cancel the negative to each other. Then why instead you say 0? But you say 0.
So for this one right here?
Yeah, they have to cancel each other.
Yeah, so X has to be -2 to cancel.
Yeah, cancel, then it's 0 charge.
But since it's 0 charge, it has to cancel. What if we do this? If we have NO3 minus. Okay. Let's find the oxidation number for the elements in nitrate. Which one do we look at first? Nitrogen or oxygen?
Nitrogen.
Oxygen, because nitrogen's not in this list. You got to follow this list in order. If you want to have that on your little reference card, sorry, Alex, then you better. Okay? So oxygen's oxidation number is -2. There's 3 of them, so that's -6. Plus whatever it is for nitrogen, there's only 1 of them. This time it's going to equal what? -1, because that's the charge. But most compounds are going to be neutral. That's true. But you got to check. Okay? And so we add 6 to both sides, and this oxidation number is going to be +5. Good? All right. Oh, we did all that work just so we can figure out which one is oxidized and which one is reduced. So I like to start with reduced because it just says which one is lowered in oxidation number. So which one is lowered? Oxygen is. And I could have went from here or to there, doesn't matter, right? So that's reduced. And which one is oxidized? The one that goes up. Yeah. Carbon goes from a negative value to a positive value. Good? And that means it lost electrons because it went positive. Good? Did I answer your question there? Okay. Anything else? Yeah, Andrew. And then
I
Chad.
think I need more practice. So like number 4, identify the oxidation numbers for elements and compounds, ionic and covalent.
So we did the covalent. You want to do an ionic?
Sure. Yeah.
Okay.
Well, and I have there was a question on the homework that just stumped me.
Okay.
Even after watching
Yeah, let's
the
do
video.
it. See if you have it.
So, calcium sulfate, it's asking specifically for the oxidation number of sulfur.
Okay. Yeah, so this one has both ionic bonds and covalent bonds. So we kind of have to do them both together, right? But let's do what we know. Do we know the oxidation number for calcium? It's a metal. +2, right? So for ions, their oxidation number is going to be their charge. What's the oxidation number for SO4? -2, right? But we don't care about the oxidation number for SO4, so we have to kind of break it apart. So this is +2. Now, we can either bring this down here and do SO4 2- and figure it out there, or we could just figure it out as a whole. What would you rather? Figure it out as a whole? Let's do it both. We kind of broke it apart on this one. Let's figure it out as a whole, just to show you. All right, so I'm going to get rid of this. All right, so now we have a covalent compound here. What do we check first, sulfur or oxygen? Oxygen has an oxidation number of what compared to on this chart? -2. There's 4 of them, so that's -4. Whoops. -8. Plus whatever it is for sulfur, plus the +2 for calcium, and this is neutral, so that has to equal 0. Make sense? Yes or no? Should I do that again? Should I do that?
So, I mean, if we can back up, so we have those 4 rules for oxidation numbers. Is there an order that we should do those? So
Exactly that order that I just wrote it out.
for neutral
Hydrogen
atoms-
first, then, oh, you mean all of those rules?
Yeah.
No.
I guess this is
I mean,
defining-
You do whatever one is applicable,
Okay.
right? So the first one is if it's a neutral atom, it's 0, you're done,
Right.
right? If it's not a neutral atom, you don't use that one, right? Or sorry, if it's just a single atom, single element, or a diatomic molecule, then it's 0. And if it's not one of those, then you move on to the next one, right?
So maybe
And
I
it-
just
and
don't
if it's-
understand what an oxidation number is, like, because sometimes it's a charge, sometimes it's not, like, what does that number mean?
It's basically its charge, but it's not exactly its charge. When we deal with covalent compounds don't have charge, right? When we deal with ionic compounds, it's exactly its charge, right? So whatever the charge is, that's what the oxidation number is. But for covalent, that's why we have to follow this little chart in order. Because, well, and this is its charge if it were an ionic compound anyway. So that's nice. It kind of helps us so we don't have to remember something else. Yeah?
I like the definition that our textbook gave on oxidation numbers. So
Okay.
it says that it's, the oxidation number is a number that indicates whether an atom is neutral, electron rich, or electron poor. So when we assign a value, when we assign the oxidation number, it tells, we can compare whether that oxidation number before or after a reaction has gained or lost shares in electrons.
Yeah. That's basically the definition.
They're kind of just a way to keep track of what happens in a redox reaction, like where the electrons are moving.
Yeah, so yeah, it's just a number to give to help determine whether it loses or gains electrons.
And that's why it's different from its charge. So those are the distinctions between its charge, if it's a charged particle, or what it's, if it's likely to, how it's likely to react in a redox reaction, as far as where the electrons move to.
Did that help?
A little bit.
Okay,
Just conceptually, that's what
No, thank-
oxidation numbers are all about.
thank you. All right, so we add these, and we get x minus 6 equals 0, so that means x has to be positive 6. What? Oh, yes. Do I need to go through that again, or how are we feeling?
That's all right, I'll just practice.
Okay? Yeah, Chad.
Um,
Is that good on oxidation numbers, guys? And yeah, we do need to practice before we take the exam, right? Get good at it. Yeah, another question on oxidation numbers?
So for when we predict the products of reactions, we have to do that too?
Not quite. So there's a few different types of reactions we can predict. So mostly we learned how to predict double replacement, right? So that's just ionic compounds. We got to know the charge of the ions, then you cross the charges and you simplify. Yes, after we deal with Chad's question. Is that okay? Any other questions on oxidation numbers? All right, Chad, go ahead.
This was from the chapter 5 homework. It was, separating certain reactions into a precipitation reaction or a non-precipitation reaction.
Okay.
And I just had a question as to why sulfur plus oxygen gas, because that becomes sulfur dioxide. And I thought it was gonna be a precipitation reaction because it didn't follow like the table of like what's soluble or what's not. But it was actually non-precipitation reaction, I was just wondering that.
Here we go. So if we have sulfur added to oxygen, or reacts to oxygen, right? Then we can only get some sulfur oxide, right? And does it tell us it's SO2?
Yeah.
Yeah. Okay, so it's SO2, and I wouldn't ever give you one of those to predict exactly what that is unless this was a metal. Then you could do it, right?
Yeah.
Okay. So they tell us this. Is this a double replacement reaction? Then it's never going to be a precipitation reaction, right? Precipitation reactions are always double replacement reactions. Acid-base are always double replacement reactions.
This is a redox.
And if it's not a double replacement reaction, then it either is a redox reaction or it's none of them, right?
So if it's not double replacement, it can't be a precipitation reaction.
That's right, or acid-base. Yep.
Question number 2.
How can we know, when one, reaction is a synthesis reaction?
A what? A synthesis? Synthesis means we take two components and we combine them together. This is a synthesis reaction. Was that on the homework? Was that on?
I'm just looking to the notes we
So
have.
here's what I need you to know about those. I told you a few other types of reactions: synthesis, combustion, single replacement, or decomposition, right? All of those that are not double replacement reactions are potential oxidation reduction reactions. That's what I need you to know there. Good? Okay, Mariana, you had a question on what again?
Predicting products of reactions.
Okay, yeah. So if we have, let's say, plus, let's do, okay, what type of reaction is this? We don't see the products, but what type of reaction is this?
Poly?
Well, maybe. It may or may not be. It's a double replacement reaction for sure. Why? We have an ionic compound in aqueous solution, another ionic compound in aqueous solution. This tells us it's a double replacement reaction. And so what does that mean we do? The nickel's going to hook up with the phosphate, and the sodium's going to hook up with the nitrate. Now, here's where you got to use what we learned last unit to write in the correct chemical formula. So we take nickel. Oh, that's a transition metal. Do we know it's charged by looking at the periodic table? So we have to figure out what it is. This way, right? Kind of like the oxidation numbers, right? What's the charge of nitrate? -1. And we do need to know this. So if you don't know these yet, I hope you have room on your little card. Okay? But there's two of them, so that's a total charge of -2. This is an ionic compound. It must be neutral, so this side has to be +2. There's only one nickel, so it's going to take the whole charge. So that's a nickel 2+. You following me?
You don't have to separate the nitrate, right?
No, you do not. Nitrate is an anion. So this, we're not dealing with oxidation numbers. I don't care what the oxidation number for nitrogen is. I just want to know what its charge is so that I can predict what the formula is. And how to do that is you take nickel, it's a 2+, it's going to hook up with phosphate, PO4 3-, right? Another thing we have to know. Then you take these numbers and you cross them down, and that's going to be Ni3 PO4 2. Is that going to be a solid or aqueous? Is it going to be soluble or insoluble? Is phosphorus soluble or insoluble?
It's now a daily sign.
It's not on our chart. You either have to memorize that chart or put it on your little card.
The oxidation.
If I were you, I would do both if you have to, but get it down because next unit we're talking about something else, and you still need to know that. So this is going to be a solid because that's insoluble compound because it's not on our chart, right? And then sodium is going to hook up with nitrate. Sodium is Na+, that's on the periodic table. It's in group 1. With me? And nitrate is NO3-. We just have to know it's a 1-to-1 ratio. We don't need to write those ones, so it's going to be NaNO3. And this one is aqueous or soluble because it's with sodium and it's with nitrate, according to that chart. Good? How are we feeling? What if I have this, aluminum with oxygen? Can you predict that product? Is this a double replacement reaction? No, this is aluminum solid, gaseous oxygen. So this is an oxidation reduction reaction. Ooh, I didn't show you how to predict this, did I? Can we? Aluminum is a metal, oxygen is a nonmetal. What kind of compound is it going to create? An ionic compound, aluminum oxide. Well, what's the chemical formula for aluminum oxide? Al2, you cross the charges, right? O3. So that one would be fair to put on the exam. Not this one. Okay.
Sorry, I forget, is that a solid or
This one?
an ionic compound?
Most likely a solid,
Okay,
because it's not an aqueous solution, right?
right.
We don't have to worry about looking at, it's not in water, so we don't have to look at the solubility chart. Good? Yeah, Andrew.
It's probably just me, but I wrote down gas-forming reactions. I think that was as a result of the lab from like last week.
Okay.
Did we cover those?
Gas forming reactions?
Yeah, because I know precipitation forms a solid and acid-base is a neutralization for water, right? But did we cover gas-forming? Do
Well,
those?
here's one. We didn't specifically say it's a gas forming, but if we have C8H18, this is gasoline. Well, that's a liquid, right? Okay. Plus O2, but really this is a gas because it doesn't burn as a liquid. It has to be in gaseous form. and we get carbon dioxide gas and water as a gas. So I mean, there are other reactions, like if we have aluminum, and we did this one in class. So solid aluminum with hydrochloric acid. We did that, and I kind of offended people on the second row here, did I? I did this in my other class last time. This time I got me. Yeah, I'm sorry, that was bad. But anyway, this is a single replacement reaction. Let's predict this. Well, in a single replacement reaction, this thing comes off and knocks off the other, because this would normally be a cation if it's within a compound, right? So it's going to kick off the other cation, and it's going to form AlCl3. Get the charges and you cross them, right? And then it knocks off hydrogen by itself, so what's it going to be? H2, because it's a diatomic molecule. That forms gas. And as we saw, right? It bubbled up. Anything that bubbles forms gas. But we don't really have a special name for that one.
So it's not like redox, it's not.
Well, it's a redox. This is a redox. If it forms a solid, it's precipitation. If it forms liquid water, it's acid base. So I guess if it forms a gas, then it's redox.
Okay.
But it doesn't have to form a gas to be redox.
So
Yeah.
how do you remember that it is acid base or solid?
What's that?
How do you remember that it is solid or acid base?
I'll show you in just a sec.
Plus it's not double replacement, right?
Yeah, this is not, that's the easiest way to tell if it's, yeah, it's not double replacement, so it must be oxidation reduction. Okay? So how do you tell, say that again?
It is solid or it is acid base reaction.
Okay. So if it's a double replacement reaction, it's either precipitation or acid base, right? How do you tell if it's an acid base? First of all, it has to have acid. Does it have to be sulfuric acid? No. Just an acid. How do you tell if it's an acid? The hydrogen as the cation. That's an acid. Okay? And then you have to have a base. How do you know if it's a base? Hydroxide is the anion. That tells us it's a base. For now. In the last unit, we'll go a little bit deeper in acids and bases. But for now, we're just talking about a neutralization reaction. Okay? And, well, this is aqueous. If it's not aqueous, it's not an acid-base reaction. Because if it's just solid of these things, then it's just two salts putting together and nothing's going to happen. Right? But if you put salt in water and it gives off hydrogen ions and hydroxide ions, it's an acid-base reaction. Does that make sense? That's the first part that tells us it's an acid-base reaction. It's also a double replacement reaction. And so this hydrogen's going to hook up with the hydroxide and become water. There's a key indicator that it's an acid-base reaction. And the sodium's going to hook up with the sulfate, in this case, and it's going to give us, what do we call sodium sulfate? Salt. This is an ionic compound. It's going to be aqueous because it's in water, right? We get salt and water. And that's an acid base. Why is it a precipitation reaction? Because we get what? A solid forming in water. Because we get an insoluble product. Yeah? Andrew?
So, Chad, did you get your question answered?
Yeah.
Cool. I'm trying to remember why H2 plus O
Well, it's H plus and OH minus. We cross the charges,
Two,
and we get HOH. How many hydrogens are there? There's 2 of them. Can I just write it like that? Sure.
but we start with H2. I know it's diatomic, right?
Yeah, but this is an ionic compound. Why are there 2 hydrogens right there? It's not because it's diatomic. Why are there 2 hydrogens right there?
Because they were needed to, to cancel out the.
Yeah, to
So usually we can ignore, no,
well, first of all, you have to tell. So this is what we learned the very first back in last unit. How to tell between an ionic compound versus a covalent compound. Do you know how to do that?
and wow, I'm
Okay.
grateful.
Ionic compound. How do you tell if it's an ionic compound, guys?
The tables.
A metal and a nonmetal. Do you know how to tell if it's a metal? By looking at the periodic table. You got that metalloid staircase, right? Anything to the left is going to be a metal. Anything to the right is going to be a nonmetal. Except for hydrogen is going to be a nonmetal, right? Okay. If it's a metal and nonmetal, that's ionic. Are there cases where it doesn't have a metal and it's still ionic? Yeah, we just found one. How else do you tell if it's ionic?
Neutral charge.
If it has a polyatomic ion in it. Because ionic compounds are always, always, always made of 2 ions, a cation and an anion. We know this is sulfate, that's a polyatomic ion. Therefore, this is an ionic compound.
So
Same
we
thing.
can- So we can ignore like the sub,
Don't ignore anything.
okay.
No, we just have to know what each thing means. So why? Let's erase some of these circles. Sorry.
You say the ionic compound always make
Cation and anion. Yep. So why is this 2 here? Because when you have hydrogen ion, why is it 1 plus? Because it's in group 1. Sulfate ion is SO4 2 minus. Why? Because that's what sulfate is on our polyatomic ion list. Then what do? We cross these numbers down, and we get H2SO4. That's why there's a 2 there, not because hydrogen is a diatomic molecule. Because if we put hydrogen with phosphate, what's it going to be? H3PO4. Right? But then when you break this up into an ionic equation, you break it up into its ions. There's 3 hydrogen ions. The charge of hydrogen is not 3 plus, right? It's always 1 plus, but there's 3 of them. There's 1 of those, and that's PO4, and the charge of that is 3 minus. Does that help?
Yeah, just, like, I know, I'm just bringing it today.
No.
I think.
Just think about it.
It's not because hydrogen is an exception right now, right?
No.
Because whenever we do like double replacements or whatever, it seems like we pay attention to that subscript or whatever. To balance and to.
Well, we
find the product and all that, right? But
we don't.
this time it feels like we're ignoring.
We don't. We never do.
We don't?
No, to determine what the products are, we look at the charge of those ions, and then we cross those charges. That's how we form those products or predict those products. We never look at the subscripts. Sometimes they work out to be the same, but not always. I wouldn't try to remember it that way. Just know how to write the chemical formula of an ionic compound.
I thought we did use the subscripts for that, but maybe not. Okay.
Good? Okay, Mariana, did you have a question? No? Okay. Oh, you had your hand up, okay. All right, is this helping? Okay, what else? Yeah, Lucas.
Can we do a problem with calculating percentage yield? Because there were a couple in the homework that were where you're given the mass of a certain compound in grams, and then they ask you to calculate percentage yield. Can we do some of those problems?
Yeah. So let's do, you want a simple equation or a more complex equation? Complex? All right. PV NO plus gives us PV3 and PO4 plus KNO3. So this is an example. I guess I should have had you guys do this. And we get, that's a solid because it's insoluble, right? It's not on our chart, so it's insoluble. Okay, let's say we have 10 grams of this and 10 grams of this, and we want to know how many grams of this we get, right? Because this is really our only product, right? We don't really get that anyway, because it's still dissociated in water, right? Yes, no? Okay. So what do? Well, actually, let's do this. I made it a little bit more complex, and I'm not going to teach you that way. We'll just say we have excess this stuff. Okay? We have more than enough. We don't have to worry about if it reacts all the way or not. Yeah?
And just quick clarification, so the potassium nitrate would be the spectator, those would be the spectator.
Potassium and nitrate will be the spectator atoms. Yep, that's right. Okay? All right, so we got to figure out, so this is kind of what you're asking, right? Okay, so we're going to start with what we know, 10 grams of PbNO3. And we got to convert this to what? In the end, we got to convert it to grams of lead phosphate, right? Okay, so what do we do first? Go to the mole roadmap. And Alex, don't forget to get one of these from me, because you wanted one of the ones with that mole roadmap that's extended a little bit. You can get it right now if you want. And we won't use this part for this exam, but just so you have it. All right. So what do we got to do to convert grams? Look at our mole roadmap. What do we convert it to?
You have to write the grams, the
Moles, right? And how do we do that?
1 mole down.
Molar mass, yeah. Well, not 1 mole down, because moles don't cancel with grams. So 1 mole
1 mole is
of lead nitrate has a mass of what? Lead is 207-ish. I rounded that, but that's because I don't remember exactly what it is. How many nitrogens are there? 2 of them, 14 apiece. That's going to be about 28, and I'm just rounding these. If you want the exact answer in our multiple choice, then don't round them yet, right? Okay. And then how many oxygens do we have? 6 times 16 is 96. And we add those together and we get something. 303, 331. Did I do my math right? Always use a calculator, guys. Okay, we'll finish this, then we'll take a break, and then, unless you guys don't have any questions. But anyway, okay. So grams of lead nitrate go away. Good. Now what do we do? We're at moles. What do we do?
Now we can convert moles of lead nitrate to moles of lead.
Yeah, so what did I forget? Oh, we have to have a balanced equation, right? Must have a balanced equation. So let's balance this. So So we got 2 nitrates, so we better put a 2 right there. 2 potassiums, oh, there's a 3. So we got to put probably a 6 here, yeah? It's my guess. Yeah. 6 potassiums, 6 nitrates, and so we're going to have to put a 3 right there, and there we go. Everything's all balanced. Good? Or do I need to go slower through that? I can. Should I? I'm hearing no's. If I hear one yes, I'll do it. Nope.
Maybe after you finish this one, you can go back to it.
So is the 10 grams for the 1 mole or including the 3 moles out?
No, we just have 10 grams.
Okay.
This right here is the recipe.
Right.
But we only have 10 grams. We don't know how many moles that is yet.
Okay.
But this is just a recipe.
Yeah. Okay.
Okay? And so now that we have moles of lead nitrate, we're going to use the mole to mole ratio. So what goes on bottom? How many moles of lead nitrate? Does everybody understand that? We have 3 in front of lead nitrate, so a 3 goes there. And we're looking for this, so how many moles of that goes up top? Just 1. That goes away. Okay, now we got to go to grams because that's what our question asked, right? So now we got to convert that into grams using molar mass, right? You all following me? So the molar mass of this is 207 times 3, 621, yeah? Plus phosphorus times 2. Phosphorus, I think, is 30. Is there a 31? Somebody check. Is it 31?
30.97.
Okay, 31 times 2 is 62. Plus 8 oxygens. 8 times 16. Something. 80 plus 48. 128. And I'm just doing this in my head, guys. Don't do this in your head, please. Use a calculator. And we get 749, 811 grams of PB3PO4 to 1 mole. Does everybody follow what I did? Anybody have a question? Yeah.
So the actual yield and the theoretical yield, they'll always be grams, right?
Not necessarily. Whatever they're dealing with. Now, in real life, yes. But on a chemistry problem, we could do moles. That's fine. Okay. All right, so then we're left with grams of lead phosphate, and that's what we're looking for. So now we do our math. I'm not going to do this in my head. You guys pull out your calculator. 10, divide 3, 31. Divide 3, multiply 8, 11. What do we get? 8.17 grams of lead phosphate. So what is this? What do we call that? This is our theoretical yield. In theory, this is what we should get. Why is it? What's our actual yield?
The 10 grams.
That's what we start with. That's what we actually start with. But our actual yield is still the amount of product, but what is it? The amount of product we actually get when we physically do this lab, right? And so on the exam, that will be given to you, okay? So there's my theoretical yield. We do this stoichiometry just so that we can find the theoretical yield. So we can know, okay, if I do 100% lab here without any errors, this is what I'm going to get. Good? Okay. So now the question's going to say, okay, what if we get 7.5 grams of lead phosphate? What's my percent yield? Whoops. Yeah, my actual yield divided by my theoretical yield, then what? Change it to percentage, right? And we get something. I'm not going to do this in my head either. 92% yield. If I says, what's my percent error? What is it? 8% error, right? Okay, yeah, Chad.
So in that homework assignment, it gave us the percent yield, and so when we solved the theoretical yields, we would just plug those into that equation.
Yes.
And then just.
Yep. So we just use basic algebra to plug in what we know. Yep. But I don't like that kind of question because it's
So I had to change it from like a percentage.
it's not real. but theoretically, yeah, that's how you do it. Yep. Does that make sense to everybody? Did that help?
Yeah, thank you.
I know that was, I did a big bulky one, but that's the process you do it always. You use stoichiometry to figure out your theoretical yield, and you're given an actual yield. It's just a ratio of those, and then times 100, right?
Could you just go over some more slowly, what you balance?
Oh, yep, yeah, let's do it.
So I get caught up with,
You want me to do the same one?
that'd be great actually.
PB and,
I sometimes have a hard time when there's a polyatomic ion in there, and I also like, I don't know.
yeah, let's do it. KNO3 plus PB. Okay. So let's show my work, break it down, because you guys have scratch paper on the exam. You can do all this, right? So we got lead on both sides. We got nitrate on both sides. You guys like to use nitrate or just keep everything separate?
I wanna get better at keeping it together.
Okay.
You know,
So what's the best way? Whatever way you can do. NO3, we got potassium on both sides, and we got phosphate on both sides. Okay, we good so far? All right. So where's a good place to start? Why this one?
because that's more subscripts.
Largest subscripts, right? Start with the big. Do you have to start there, guys? No. But if you don't, you'll probably have to change some stuff. And just saying that's the easiest place to start. All right, so let's do lead. We have 3 leads on the right. So we need to put a 3 right there, right? So when I balanced this, I didn't start with lead, did I? And then I had to change it in my mind. That's what's going to happen. It still worked, but you'll just have to change it. So we got 3 leads on both sides. Everybody good with that one? Okay. Now let's do phosphates. How many phosphates do we have on the right? 2. So we better put a what here? A 2. 2 phosphates on both sides. Woohoo. Okay. Question? Okay. Now let's do nitrate. How many nitrates do we have on the left? 6. So we better put a 6 here. And that gives us how many potassiums? 6 and 6. Not too bad. If you start in the right spot, it usually just goes pretty smoothly. But when I did this, I was kind of just trying to rush. That's what happens when you try to rush yourself. It's gonna take longer. When you try to go faster, it usually takes longer. Not always, but okay. Any other questions? Well, should we take a break, or how you feeling? Okay, let's take a break. Okay, so far this has been a pretty good review. In fact, it's better than any other review I've ever had. And it's because of you guys coming with questions. So what else? Yeah, Chad.
I have more questions with balancing equations.
Yeah?
So I guess it should be simple, but.
No, let's do it.
So it's from one of the worksheets, iron oxide, FeO, plus oxygen gas.
FeO. Okay.
That's
We get-
Fe2O3.
All right.
Can you tell us which worksheet, Chad?
It is just the balance, it's equations. So, and then it goes into like oxidation numbers on the back, but on the front side it's the balancing.
So we just have two elements here. Where do you want to start?
I started on both and I get stuff.
Okay.
So,
Should we start with iron? Why is iron a better place to start?
It's first one.
Because oxygen is everywhere.
even though oxygen.
And-
has substrates.
And it's alone.
What do you mean by that?
It's all by itself right here.
Oh, right.
So according to our tips and tricks, let's leave oxygen for last. Now, that's generally what we should do. In this case, it might be better to start with oxygen. Why is that? Actually, it's not. It's still better to start with iron here. And how do you know? You might not. And it's okay. It really is. Do you want to start with oxygen just to show you? It won't matter. We should still be able to do it. Okay? So let's do oxygen. How many oxygens do we have on the left? How many on the right? Didn't do anything anyway, right? Okay? It's not always going to be exactly like that. But we have two irons on this side. So we better put a what here? A 2. Okay. Now, there's how many oxygens on the left? 4. How many on the right? So it's not there yet. We got to just keep going. So here's what I think about. This is always going to be even because of that 2. This is always going to be even because of that 2. This is always going to be odd. Odd can't ever be even. So let's make it even. How do we make this side even? Put a 2 there. No? Because if we put a 2 here, now there's 6 oxygens on this side. And we just changed the iron, so we got to... Okay, now there's 4 irons. So we better put a 4 right here. I'm going to save that one for last because it's all by itself. So if that's the last one I put something, it's not going to change iron anymore. Right? So now I count. There's 6 oxygens on the left, on the right. There's 4 here. Oh, there's 6 on the left too. We're done.
So, yeah, because I was getting stuck when I was getting the 4 and the 3, and so.
So
just
wh-
type by 2,
what I do is try to make both sides even.
and if you just do that, you can.
Multiply an odd number by 2 always will give you an even number.
And then just kind of fix things.
Uh-huh.
Okay.
Yep.
Could you also do,
I'll get with you right next, Rebecca. Go ahead.
sodium nitrate, sodium, I guess, nitrite,
NaNO2.
plus O2.
Okay. All right. You want me to show my work again? Okay.
Because this one, the polyatomic ion.
Yeah, it's not the same on both sides, so you can't treat it as the same unit. So you have to do everything separately. Okay. All right, so where should we start?
Sodium? No,
It's done.
same.
Nitrogen, done. Oh, we have to start with oxygen here
Why can't we do nitrogen?
because it's already done.
Oh, yeah,
Right. So, no big deal. Okay, let's do oxygen.
It's for us.
Same thing. I see 4 on one side and 3 on the other side.
Times that one by 2.
Times this one by 2. And now we have 6 oxygens. So before we do the other oxygen, I still want to save that one for very last.
So you can't take a
Let's,
break from oxygen.
yeah, let's take a break from oxygen. We have 2 sodiums, so I better put a 2 right there. 2 nitrogens, 2 nitrogens. Okay. So now let's do the oxygens. There's 6 on this side, and we have a total of 4 here plus 2 here. Done. And the common thing that people do on this particular one is to say, oh, there's 6 on this side, so I better put a 3 right here, or a 2 right here to make it, right? Save that one for last.
Okay. Thank you.
Yep. We good on balance? Any other question on balancing? Yeah.
How do we know when we can use as a half? Do we use 1/2 every time it's like enough?
You can anytime. Anytime you want. If you can balance the equation using a fraction, then do it. If you don't need a fraction, don't do it. That makes it worse, right?
Well, like when you recommend to use it, when there's like enough odd numbers?
Yeah, usually. So like usually it happens, and I'm not saying always, but usually it happens when we have like an element by itself, like O2, for example. We have odd on one side, and then you have a 2 right here. Another way around that is just multiply that odd side by 2, and then try to do it. So you can do it without doing fractions, because you have to multiply by 2 anyway, or something to get rid of that fraction. You want to do one? Say, yeah, you do? Okay. Let's do C8H18 plus O2 gives us CO2 and water. Okay. We have carbon, hydrogen, and oxygen. Let's start with carbon. This compound anyway, right? So we have 8 on the left. So what goes here? 8. And then we have 18 here, so what goes there? 9. Now we can count the oxygens. We have 8 here plus 9 here. That's a total of 17. Odd on one side, even on the other side. Do you want to use a fraction or get rid of the odds? Your call.
Let's try the odds.
Get rid of the odds? All right. So this side's going to be even. This side's even. This one right here is odd. Always. 9 times 1, that's odd. So how do we make that one even? Multiply 2 to that one, right? There, now it's not even. Okay, so let's do it. So we got But here we have, and I can start counting the oxygens if I want, but I just changed the hydrogens, so I know this is wrong. So that means I have to multiply this one by 2. That's 18 times 2, that's 36. So we have to have 36 on this side.
That's
Oh, whoops. Thank you. Good? And then, all right, now let's do carbon. We just changed the carbon. Now it's 16. So what has to go here? A 16. You see why I changed this one, so rather than counting oxygens, because I'm going to have to change it anyway. And if you didn't see that, no big deal. You'll just have to cross out or erase more often. But you still should be able to do it. So now let's count the oxygens. There's 16 here, plus 18 here. That's a total of 34. So what has to go here to make 34? 17. So we did that without fractions, but maybe it's easier with fractions, because then you just multiply everything by 2 and you're done, right? Because we had to multiply everything by 2 anyway, right? It doesn't matter how you do it. It really doesn't. You don't have to follow tips and tricks, but sometimes you got to be a little creative to get it to match. Good. Anything else on balancing? Okay, other questions? Oh, yeah, you have a question on balancing?
Yeah, so, where is it? It's on the chemical quantities worksheet.
Uh-huh.
There's, section 5, mole relationship. There's 3 equations. And then there's the middle one.
Section 5, you say?
Mole relationship.
The what one?
Mole relationship.
Okay, maybe I'm looking at the wrong one. Yeah. Oh, quantities, yeah. Section 5. Okay, yeah, which one? First, second, or third?
The second one.
Okay. So the second one says, how many moles of XEF2
Would be required to produce.
Balanced it, the answer was right, but I put 1 mole of XeF2 and 2 moles of HF, but then on the key it says 2 and 4.
Okay, let's see.
I don't know.
So maybe we did it wrong. So XEF2, here's our equation, plus H2O gives us Xe plus HF plus O2.
Is it mole relationship? Is it on the mole?
Yeah, this one's the mole-to-mole relationship.
Mole relationship.
Yep.
First one?
All right, so let's balance this. We got X, E, F, H, and O. Okay. So where's a good place to start? F. So there's two fluorines on the left, so we better put a 2 right here. You following? All right, that has 2 hydrogens, and then 1 Xe, 1 Xe. Oxygen, that tells us we have to put a 2 right here, right? You following? So now there's 2 oxygens, but now we have to count the hydrogens all over again. There's 4 here, So we got to put a 4 right here. Now there's 4 fluorines, so we got to put a 2 right here. Now there's 2 xenons. Oh, that's nice. A little messy, but
I put 1 and 2, but I still got the same answer.
okay. You might have got lucky on that one. Because do you have to deal with all of them for mole to mole? So you might have got that one substance balanced correctly, but then you didn't use the other one, so it didn't matter. And that's why it worked. Good? So double check, make sure you have it balanced right. You got lucky that time. So maybe other times too, but be careful. I would just double check, make sure you have it balanced. After you're done, count again. Make sure it's right. Do you want to continue with this problem or? Okay. Yeah, Lucas.
Can you not reduce this by just dividing by 2?
No, because of that one right there. But yeah, it should be simplified. But here, that one doesn't have a 2, so we're good.
Because if it did, then you should always answer it the lowest possible.
Always. And would it be okay if you didn't? In real life, it would be. It's just like you're doubling the recipe, right? You're still going to get good cookies. If you double everything, better because you get more, right? Okay. But yeah, okay. But on the test, yeah, you should probably have it simplified. Because as people, we like things simple. Do you have a question, Andrew?
Yeah, just wonder, do we need, so number 1 says, or on the study guide, know the different types of chemical reaction and be able to classify the equation. Do we just need to know like single, double precipitation? Or do we
Precipitation.
Know, like, if it's a redox, do we need to know decomposition?
No.
synthesis?
Precipitation, acid base, and redox.
Okay. I didn't know if like those were classifications of a redox or like what the difference
Yeah,
is,
what we deal with in this class is just those 3.
just those 3.
Yep.
That's the
Okay.
kind of, yes.
Yeah. That's right.
I'm looking at number 14 on the study guide. Are we always going to be given, like the example I have in my notes is 2H2O plus 572 kilojoules turns into 2H2 plus O2.
Uh-huh.
And it says that we were given 2 liters of H2 and we're trying to find the heat and we were given the density. Are we always going to be given like the liters and the density? Or,
Only if you need it,
okay.
right? If you're just given grams, and you could do it that way, right? You don't have to worry about the density. But if they give you volume, yeah, we will give you the density.
And then also, can we go over number 18, please?
Number 18.
Yeah,
Okay, it says, know how to write an equilibrium equation for a given reaction. So do you want to do simple or hard? Okay. So let's do middle. How's that? Or should we do hard? Hard. Okay. Let's just do this last one we did, because this one was icky. All right, before we can find the equilibrium constant K, so that's what it's asking, right? Write the equilibrium equation for a given reaction. So we're saying products over,
Find out K.
yeah. And so if, there's something like that, right? So maybe it's worded a little bit off there, but this is kind of what you need to be able to do. Does anybody want to go over this one still? Okay. All right, so what do we have to do first? Balance the equation. And we do this, and we're gonna get 3 here, 2 there, and 6 there. We already balanced this one before, right? Okay, so what goes on top? The products of the reactants. Products go on top. So PB3PO4 2 in brackets raised to what power? The 1 power, because it doesn't have a coefficient, or the coefficient is 1, times KNO3 in brackets with the exponent of 6. And then on bottom, PBNO3 2 with a exponent of 3. And then K3PO4 with the exponent of 2. And then if you're given numbers, can you calculate K? Or if you're given K, can you calculate a concentration of one of those substances?
Can we do
Yep.
an example of that?
Yeah.
Or we're given-
Should we do this one because it's already set up? Okay. So let's say, I'm just going to write it on top just for less writing. Is that okay? So if we have, let's say, 0.54 moles per liter of this substance and 0.96 moles per liter of this substance, and we have 0.68 moles per liter of this substance. Well, we want to know what's the concentration of this substance. We're good? Okay, so that means we got to solve for that guy. Or should I solve for a different one? What would you rather me solve for? This one? I won't ever give you one with the 6, because that's, whew. But do you know how to do it? If I give you that one? If we have x to the 6th equals 39, can you guys solve for x? The 6th root of, how do you do that in your calculator? Raised to the 1/6 power. But don't worry about it. We won't do that to you. Okay? All right, should we just solve for this one right here? Or should we solve for this one right here because it has a squared? Because you might see that one. Should we do that one? All right, then let's do... Let's say this one right here is 0.68 moles per liter. And this one right here we're looking for. Oh, no, not that one. Sorry. Let's say this one right here is 0.96 moles per liter. And we want to know what that one is. Good? All right, so we just plug this in our, it would have to be given K. This is going to be way off because I don't know what K is, but let's just say K is 2.96 times 10 to the negative 2. Okay? So yeah, this is probably going to be, we might get a invalid, or you take the square root of a negative number, it's not going to work, right? But that's what happens when you just do it on the spot. But the math is all the same. Okay. Oops, we need that shown. All right, so K is 2.96 times 10 to the negative 2 equals, and we know this is 0.96 Do we have to worry about the units? No, they all cancel out. Except for you got to know that since these are all moles per liter, your answer is going to be measured in moles per liter, right? Okay, so let's just leave out the units because it's a little bit messy anyway, right? So 0.96, because that's the concentration of lead phosphate. Potassium nitrate is 0.68 over this one is 0.54. Y'all following me? Or am I going too quick? And we're looking for this guy right here. Can I just call it X?
Can you
Okay.
exponents?
Yeah, yes. Good catch. Can I just call it X? Is that okay? Yeah, don't forget the exponents like I just did. Okay? All right, so now, do you want to solve for X first or kind of simplify it a little bit? Simplify, okay. So we do order of operation, we got to do 0.68 raised to the 6th power, and we got to do 0.54 raised to the 3rd power. So we can rewrite this as 0.96. And what is 0.68 raised to the 6th power?
0.0988.
Okay. And what's 0.54 raised to the 3rd power? And this is just going to be x squared. We good so far? All right. Now let's, should we simplify by figuring out what that is? Do 0.96 multiply 0.09887 divided by 0.157. You following? And we get, I'll just rewrite it down here, 2.96 times 10 to the negative 2 equals, somebody calculate that for me. 0.96 multiply 0.09887 divided by 0.157.
.605.
0.605. And that x squared is still on the bottom, right? Following me okay? All right. So now what do we do mathematically? Yeah. We can either put a 1 right there and just flip both sides. You guys like that okay? Or we can cross multiply, whatever you want to do. There's a lot of different ways to do this. Okay? So if we cross multiply, we're still going to have to do something. So it's going to be x squared multiply 2.96 times 10 to the negative 2 equals 0.605. Good? Then we divide both sides by 2.96 times 10 to the negative 2. Can we write this inside in regular notation if we want? We can. No big deal. 0.0296. If that's easier for us. Or we just type it in our calculator. No big deal. And so now we have x squared is equal to 0.605 divided by 0.0296. Simplify it. What's 0.605 divided by 0.0296? What? 20.42? 44? All right. So now we have x squared is equal to 20.44. So what do? Square root both sides. X equals something. 4 point something. And and that's gonna be moles per liter. And so that's the concentration of potassium phosphate. Little mathy.
Now, would you write it, as the, like, 3 PbNO3 subscript 2 would equal 4?
Yeah, I would do, so is solving for this guy right here. So it'd say concentration of K3PO4 is 4.52 moles per liter.
And you wouldn't put the exponent?
No, we would not.
Okay, it's just that.
We're just looking for the concentration. Because we square rooted that, right? And got rid of that exponent. Yep. And if changing it to X throws you off, then don't change it to X. Yeah.
Question.
I have a separate question as well. If we-
Are we good with this?
I have questions.
Okay. Yeah, I'll get you after Chad. Go ahead, Chad.
In the homework for our most recent unit,
Uh-huh.
well, I guess for chapter 7, there's just a term, it says endergonic or exergonic.
Okay.
Is that the same as endothermic and exothermic?
No. So delta H as a negative means exothermic, right? And positive delta H is endothermic. Well, just like negative, because a lot of times delta H and delta G are the same sign, right? So negative delta G is called exergonic. And I don't remember if I told you this. I might have just told you by the passing, but not really. And then positive delta G would be what? Endergonic.
Because it gives us 2 graphs of different reactions, and it says one of the things we're comparing is if it's endergonic or exergonic.
Yeah, and on the exam, I'm just going to say spontaneous or non-spontaneous.
Oh, okay, so like
So
exergonic is synonymous.
this is spontaneous.
And that's not.
Yep, and this is non-spontaneous. Yep, it's just a different word. We good there? Endergonic.
Question number 7.
Number 7? Yeah. So number 7 on the study guide says, know how to determine the number of atoms there are in a given number of moles of an atom. So if we have 3.5 moles of what atom do you want to deal with? Gold?
Can we say carbon?
Sure, let's do carbon. And I want to know how many atoms of carbon we have, right? So where do we start? With what we know. We know we have 3.5 moles of carbon. How do I convert moles to atoms? Avogadro's number. What goes on bottom? How many? Yeah, if we have 1 mole of carbon, we know we have 6.022 times 10 to the 23 atoms of carbon. It's just a conversion. But we need to know that conversion. And again, after this exam, we won't. I mean, we still need to know that conversion, but I'm not going to ask you to do that. I may on the final, I don't remember. Yeah. Did that help, Amon?
This is just you do multiply 3.5 by 600. That's it.
That's it.
You don't have to divide because it's 1.
Yeah. That's it. And so if we get an answer, it's gonna be what? 3.5 times 6.022 E23, and we get 2.11 times 10 to the 24 atoms of carbon. Good?
Yeah, thank you.
Can you do that on your do you have your calculator?
No, that's right.
Okay.
Yeah, I
Make
have to
make
do
sure
it.
you have it. Yeah.
Number 18, they'll have to write the equilibrium equation for a given reaction.
Yeah.
That's like a word problem almost.
We did this right here.
Number 18.
So basically, come up with that formula.
Sorry, so I thought that was 19 was to figure out, to figure out K.
Yeah, and then we did number 19 right here. Well, in this case, we didn't calculate K. But if we did calculate K, that would have been easier than the one we did.
So knowing how to write it is just,
The products raised to the coefficient power,
okay,
multiplied each other, divided by the reactants raised to their powers, multiplied each other. That's it.
I didn't know if there was.
And you have to know how to do that in order to do number 19, right? Anything else? Yeah.
Yeah, there were a couple questions in the homework about how to determine whether reactants or products are favored in a reaction. And there were certain things that could influence like the favorability, like delta S and things like that.
So being favorable, that's going to be like what we talked about with Le Chatelier's principle. If you increase the concentration of one of the reactants, it's going to push it to the product side. If you increase the concentration of one of the products, it's going to push it to the reactant side. Okay, so that's how you determine favorability. Good.
Do we need to know also like how changing the delta S or something would affect favorability one way or the other?
Do you have a specific question?
Probably would be,
Yeah, do that. That might be a little bit more useful.
yeah.
I have for question 14, if you can get an example.
Okay, which one?
14.
Okay, while you're looking that up, Lucas, let's go to number 14. Yeah, and if you guys we're going till 12:30. If you guys are good, then you don't feel like you have to stay
The
here.
exam is open.
What?
The exam is open today.
I believe it's open today.
And stay until
I
Monday.
got an exam 379.
Yeah, here we go. Anybody else need one? Okay, number 14. So it says, know how to calculate how much heat is consumed for a given amount of reactant. So, yeah, if we have H2 plus O2 gives us H2O, and let's say delta H is exothermic, so it's negative 6.102 joules. And I don't know if that's the right number, but we'll just go with that.
Yeah, we just.
Okay? So we want to know how much heat is released if we burn, let's say, 3 grams of oxygen. What?
102.
Negative 6.102.
2G.
J, joules. It's just a unit of energy. Yeah.
So, I imagine maybe it's similar, but in this, on the question on the study guide, it says how much heat is consumed for a given amount of reaction.
Oh, consumed? Okay. So then I would probably have to write this. H2O gives us
So just make it
H2 plus O2. And now this time delta H is positive 6.102.
So this is endothermic here.
Now it's endothermic, right?
Oh,
We have to give it energy to break it apart. Okay? But either way, it's the same thing. This time it's, so that says consumed. So yeah, this would specifically be in, but the math is the same.
Right.
Okay, so let's just do this. So thank you. Let's say we have 10 grams of water. We want to know how much heat is required to break down 10 grams of water into oxygen and hydrogen gas. So where do we start? 10, yeah, with what we know, 10 grams of water. And what does our mole roadmap tell us we convert it to? Moles. We got to go to moles. Before we can do anything, we have to have moles. So water has a molar mass of about 18 grams of water every 1 mole of water. And again, I rounded the 18. It should be like 18.02 or something. Okay. So that goes away. Now I'm going to convert moles of water to heat. Right? So what's the ratio? What do I have to do before I do this? Balance the equation. Okay, so let's balance this. We've got to have 2 of those and 2 of those to make it balanced. Good? All right. So now how do I convert moles of water into heat? What goes on bottom?
bottom is the
Yeah, 2, because that's the number in front of water. 2 moles of H2O so that it cancels. What goes on top?
delta
6.102 joules. That's it.
102.
And then whatever the answer is, that's it. Because we're left with joules, that's what we're looking for. And then that's how much heat is absorbed or consumed. If it's at how much heat is released,
This
then it
we
would
have to
be
divide
probably
by
that one right there, but it's the same thing, right?
mo-
What?
18 divided by 2 and then
So 10 divided by 18, because 18's on bottom.
18 divided by 18 multiplied by 2.
I wouldn't do it that way.
How?
Here's how I would do it. Do you understand how to set this up?
Yes, but
Okay, here's what I do. I start from left to right. 10. You multiply if the number's on top. You divide if the number's on bottom.
okay, multiply and divide.
So 6 or 10, divide 18, multiply 6.102, divide 2.
2.
Now, there's another way to do this. Do you like that method, or do you want me to show you another way?
I think that's easier because
It's easier for me too.
yeah, it's
Anything else? Great review, guys. I hope that was useful for you guys. Yeah, Andrew.
I'm not sure how to ask this, but I feel like at this point in the semester, my brain is just full. And I don't know if I'm getting any of this. Is there like I don't know, like how would you review for this? Or is there like a master equation we can practice all of this at once? Or like, I don't know, do you have any just general tips?
Yeah, do the practice test.
Yeah, that makes sense.
Another thing you can do is use AI. Ask AI questions. Maybe ask AI to give you a problem like one of these that's, and maybe say it just like this. AI, tell me how to know the difference between the different types of chemical reactions to be able to classify a given chemical equation. And I know AI is not perfect, If it gives you something we didn't even learn, then don't go that route, right?
All right, fair enough. Thank you.
And then just maybe go home and take a nap and then wake up refreshed and then go study for a full, right?
Thanks.
Yeah. Do you have a question?
Sorry, does someone else have a question? I just
Oh,
feel
you
like-
did?
Oh, sorry.
Go for it.
I just feel like we've gotten into the weeds so much, I feel like I need to like zoom out.
Uh-huh.
Like, I don't know how to put it, it's almost like you know all these tiny little rules, but it's hard to keep them like in line and know when to use each. Do you have a way of like zooming out? Does that make sense?
So follow this problem-solving strategy.
Okay.
And say, okay, what do you know? What are we looking for? And if there's a formula, use the formula. If it's just dimensional analysis, make sure things cancel out until you ended up with what you need. And that's going to be your best bet. Use that problem-solving strategy. That strategy is good for every problem in the universe. And then you just look at what you know, look at your reference sheet, look at your little card, look at all of the things that your periodic table, and just go from there. I know that probably didn't make it feel beautiful inside, but did you have a question, Alex?
No, I'm good.
Oh, I thought you had your hand up, okay. Anything else? Yeah.
I did find the problem that I was looking for.
Oh, good.
So, maybe zoom up a bit.
Well, it's time's up now. Let's go. I'm just kidding. We still have 7 minutes. So.
So I'm given an example of a like stand-in for a chemical equation. So if you could write it on the board, it's 2a subscript 2. So 2a2 plus b2 gives you 2a2b. You know
2A, 2B.
I thought I got it right.
All right. And so what's the question?
So it asks for the sign of delta G, delta S, and delta H.
Okay.
We're also told that the reaction is spontaneous.
So if it's spontaneous, what's delta G?
Negative? Oh no, positive.
Negative. It is
Is
negative.
it negative?
Yes.
Right. 'Cause it's
So if it matches delta H, just kind of think about our graph. So this is delta H is going down in energy, right? So we're losing energy, releasing energy. But that's also, if you take a ball and you try to roll it up the hill, you only have to roll it up the hill until you get to the top, the activation energy. Then you don't have to touch it, and it'll do it all by itself. That's what tells us it's spontaneous. And so we end with a smaller energy we started with. So final minus initial is a negative. Does that make sense? Yeah? Okay. So that's what it tells us, it's spontaneous. All right. Now, can we find delta H just by looking at this? We can't. Can we find delta S? Yeah, what is it? Is it going to be negative or positive? Negative because it goes to more or less disorder, right? So that's a negative. Now we use the equation. Does it tell us what the temperature is? But we probably don't need to worry about that anyway. Maybe we do.
No, temperature is not given.
Okay, so we have this here. So this is a negative. This is a negative. So we have a minus and negative gives us a negative answer. Minus and negative is plus, right? That means what does this have to be for us to get a negative answer? If it's positive, positive minus a negative becomes more positive. So this has to be negative. Does that make sense? If you have a negative number, let's pick any negative number you want. Negative 10. Minus, pick any other negative number. Negative 1. What's negative 10 minus a negative 1? Negative, it's still negative, right? But if we did positive 10, it's going to give you a positive 11. Or actually, it's going to give you, yeah, this would give you negative 9, right? And if that was positive, it would give you positive 11. And that's not right, so it has to be negative. And that's how you'd use that formula to figure that out. Yes or no? Okay. Anything else for the last 3 minutes? Yeah.
I guess just one question. The spectator ions in a precipitation reaction would be the solid, or sorry, the non-solid, the aqueous solution. The spectator ions in an acid-base reaction, that would
Be the non-water.
the non-water.
Yep.
Question number 4.
Number 4. Identify the oxidation number for an element in a compound. So we did go over this, but we can do it again if you'd like.
It's oxidation number. If you say, give me a simple example.
So sodium, let's do
I know you're getting to
Oxide.
in the classroom.
Yeah, you have a question, Rebecca?
Yes, I was gonna ask if, when we add heat, the pressure or whatever, the arrow goes towards the heat or like left?
So it depends on where the gases are. So when it's a pressure change, you look at where the gases are. If most of the gases are on the product side and you increase the pressure, it's going to push it the other way,
That's how you knew it was.
to the reactant side.
But I'm talking about the addition of heat, not
Oh,
pressure.
heat.
Yeah.
So you have to know if it's endothermic or exothermic. So what is that example? Is it endothermic or exothermic? Exothermic. So if you add heat, well, then it's going to push it the other way because the heat is a product, right? If you add some product, it's going to push it the other way. It always pushes it the other direction. So if it was endothermic, then it would push it toward, yeah.
I know that, I was just like, it seemed like.
Yeah? All right, thanks. Okay, so on this one I'm on. So this is an ionic compound. So what's the oxidation number for thank you, for sodium?
It's the oxidation number, electronegativity.
No. It's like the charge
Oh, the charge is
of sodium is positive 1.
positive 1, yes.
Look at your periodic table. It's in group 1. It's going to lose 1 electron, become positive 1, right? Yeah? What about oxygen?
Oxygen is 3.
Y3, Y2. Look, we're not looking at electronegativity. What's the charge? Did I say electronegativity?
No. The charge is 2 for that.
2 minus, so it's negative 2. So that's the oxidation number. That's how you do it on ionic compounds. Covalent compounds, a little bit different. Let's do
For ionic,
for ionic, you just whatever the charge is the oxidation number.
for covalent. This is covalent, carbon and hydrogen.
Yeah, this. How do you know it's covalent? There's no metal in it.
But then this one, oh, and then the sodium metal.
Yeah.
Anything in middle is ionic.
Yeah. Yep.
Hydrogen and carbon is covalent because they're non-ionic.
Yeah. Do you know how? Should we do this one?
This is, the 3 carbon is linked to this carbon has.
We don't deal with carbon. No, we don't look at charges. We have to follow this. H equals +1.
Thank you.
Thank you. Take care of you too.
It's going to be 8.
F equals -1. It's not 8. It's +1. The oxidation number is +1. Now to calculate what it is for carbon, thanks. Then we have to multiply, okay, we have to multiply that and we get +8 plus 3 times whatever it is for carbon. And this, since this is a neutral compound, the sum of those oxidation numbers has to be equal to the charge. In this case, it's 0.
Why is it?
Because the charge of this compound is 0. It's neutral.
Carbon doesn't have any.
No, it's not, has nothing to do with carbon. It's because this, when I write C3H8, is there a charge right there? No, if there's no charge, it's 0. But if we had a charge, then now it's -2,
Oh, yes.
right? If there's no number there, then its charge is 0. So it has to equal 0.
H equal, why you write iron equal to negative?
Right, what? Fluorine? Because this is the order you have to check it in.
0, yeah, exactly.
So after that, we got chlorine, bromine, and iodine, which is all -1. So if you have a covalent compound, then you have to say, okay, does it have hydrogen in it? And the answer is yes, it does. So there we go. That's it. Now we don't have to do this, worry about this anymore for this problem. We got that. It's +1. Times by 8 is +8 plus 3 times whatever it is for X. That's what we're looking for. Or for carbon. I call it X. You don't have to call it X. We can call it C if I want.
Are you going to post this by this evening or by tomorrow morning?
Yeah, I will. I was a little late on the last one, but
It's
I...
okay, but the reason tomorrow I can look a little bit at Monday. What are you doing? I can watch.
Okay.
Thank you.
Yeah, I'll do that. Yeah.
I was just gonna ask about the dates for the exam. Do you know how long the?
You have till the 10th, I believe.
Which is next Thursday.
Next Wednesday.
Next.
So, to know for sure though, I believe that's what it is, then you just go schedule a time and it'll tell you when you can.
Awesome, thank you so much.
Yep, thank you. Take care.
Bye.
Yep, see ya.
One thing it's sometimes makes me very sad. I grew up in a, I'm not this is telling to excuse something, but I'm just generally talking. I grew up from when the war started in Afghanistan. I just started the 4th grade. The war started, faction of the country went massive, totally massive. Until grade 9, I studied just what one teacher, sometimes the mathematics teacher, but only he not she anymore. Because now if you read the history of Afghanistan, Mujahideen came, then after that Taliban came, then again the other government came, then now again Taliban came. I blame this behind me. This is what I look at night. I found out in my country now. Look, it is all on grade 8, 9, 10 they are studying.
They're studying this stuff?
Yeah.
Yeah.
Ever wondered what your
Yeah, we're a little bit behind here, aren't we?
No. I know there's some people who got more than that in my school. This is, now Taliban banned this TV, but still there's like, he's teaching in my language. This is, it says grade 8.
Huh. Yeah, I think we are a little behind, education-wise.
No, the reason I'm asking that I like this past 10 years, the school situation was good. some Afghan student I saw when they say, hey, they are super easy. But here, people, why they go to school? The school is totally crushed. Because they're supposed to be know this simple stuff at school. When I watch this, I said I wish I could study this during my school time.
Yeah.
I had only one teacher. Believe me, sometimes we almost sit in grade 9 2 years. I said.
You can get started whenever you're ready.
Okay.
Do you need anything from me?
No, I got all my papers and stuff.
Okay.
So I'm gonna sit here. Maybe you should not look at the question.
No, it's okay.
I don't know.
Different
No.
class.
It hurts me, and when I learn this in my language, explain, I keep it in my language, and I'm learning, enjoying it. But unfortunately, this is what I was studying grade 8. I didn't know these nothing.
Well,
Only-
did you have a lot of videos teaching this stuff?
Yeah, there's a lot
You
of
should
videos.
watch 'em.
I'm watching, and I got some other videos in my language. I will show you. But I was watching these videos that here, moles and homework, chemical reaction. In the past, like my brothers come, they said, they also saw, they said, oh, they are now studying, they know some of them. But unfortunately, I wish I could study, even here, much better. At school, you teach students, you have this technology. The one that I studied, only one teacher, sometimes he had a big stick sit on the corner and say, I don't want to just do something, but I don't want anyone to yell something or not go quickly. I was the one that jumping every time to the restroom. He said, Aman, only you need to go 2 times. Don't ask me anymore. Just sit quiet. And he sit on the ground in the morning, eat a little bit, and window broke and stuff. But now, for this generation, you guys supposed to know this ahead of time and easy. But here, you guys supposed to get master. But it's very hurting. But it's good example that I have to
Mm-hmm.
squeeze my kids, which I'm doing.
Uh-huh.
But they are very active. My daughter, like a couple years ago, didn't listen, and I stopped her. And now she's disciplined. She learned quickly
Good.
mathematics. She has like this notes, computer. If you see her plays like an office man, many years at working city. But learning is the best thing I think. Otherwise, the same
Yeah.
thing. She has to come sit the next day. You keep teaching, and she said, "Oh, this."
Yeah. Yep, it's, and that,
Unfortunately, school, they have to give warning or they have to stop. Invite families to why your son is not giving homework, why they are not studying. They say, no, it doesn't say it's freedom. So that's the unfortunately we are doing. That's
Yeah,
why always
yeah.
we have doctor, nurses, engineers, IT from India, China. When you go to Facebook company, all of them, unfortunately, you see a few of us.
yep, different
And then
culture.
all of them foreigners.
Yep.
Which
Yep.
is good education to me, but it's now 2 years. I hired someone in India teaching my daughter mathematics. Whenever she comes at school, what did you learn? Oh, we read this, but tell me, what did you learn today? You're grade 7. Tell me in mathematics. She doesn't know it. Then I start a couple years ago, but now she's a lot better. And
Good.
But we plan to hire also chemistry, but not maybe next year. Now she's in algebra and very fast.
Good, good.
So. I hope you don't mind what I said. That's
No.
unfortunately
No,
true.
not at all.
In algebra class, I studied 990 here, and I saw everybody finish school and sit with me, say what's going on. When I studied another class of algebra, everybody just finished school and come back learning equations. Hey, did you finish school in America? I can't say if I go back at home, say people finish school learning equations, nobody believes it. So that's we have internet, food bank, access to car, but everybody's spoiled here.
Yeah.
They don't care about education.
Yep.
For
You
me,
don't have to
very
tell me.
interesting. Even I learned a little bit now, I'm proud of myself because I never heard such a stuff. What's going on?
Is there
No, I have to go
is there an English class like to learn English as a second
in my
language?
country?
No, here.
Yeah. Here or back at home?
here.
English,
Do they offer that for people that's learning English?
here, yes. Like,
So you can take a class that teaches you how to go from your native language to English?
yeah. For me,
Yeah.
do,
Can you take a class here in America
yeah,
that teaches you how to speak English?
yes.
What is it? They do offer it
For me or for
for
others?
you.
Yes.
You should take it.
You think my English is weak still?
No, just for like, because a lot of things that I tell you is like, well, what does that mean? Well, what does that mean?
Oh, I'm translating.
Oh yeah, yeah.
I'm a lot of words I'm translating, like, that I did my English classes,
And I guess it's, how long have you been in America?
9 years.
9 years.
I just started three and a half years ago education, but English only I have to learn the meaning of, like, some meaning of the sentences.
Yeah.
Today,
Yeah, it's
sometimes when it confuses me some formula and I say, oh, why this oxygen, like for example in this one, why hydrogen come the second time, since the hydrogen was the beginning and then the second formula is why it's coming the second time. But or I have to, like disorder, I have to translate this, what does it mean? Or some words that I'm keep translating in my language.
yeah,
Here I do it.
that's a lot.
But still, there's English is not the only mathematics and this chemistry. That's something that I'm facing problem. I studied here English tinting, 2000. I did.
Yeah, but
I
they
got
don't teach you how to speak English. They don't teach you what the words mean,
Yeah,
right?
this is I have to translate
Yeah.
by myself, which I'm doing. I'm translating. I already did a lot of words.
Yeah, my hat's off to you, man. That's tough.
Like here, I translated beast wars. I don't know what is it. I did in my language.
Could you copy and paste and put it in AI and say translate this?
I don't have an AI app in my.
It's on the internet.
Yeah, but I'm using Google Translate.
Let's see something real quick.
Like here, gallons. I didn't know I translated in my.
Yeah, because gallons no one uses except for here. Can I?
It's time for you to eat, so I don't.
Oh,
take
I'm
your time.
good. I'm good.
I have to leave.
Okay.
Then on Wednesday.
So if you go
Hmm.
rock.
Is it free?
Yes.
Oh, then I
Okay.
need to.
No. Now if you go here, can you come here?
Yeah, this is a.
No. Is this class? Okay, let's go to
Thank you for showing me.
go
Do you think my speaking is good?
yeah, I understand you, but when I say certain words, you
Yeah,
don't know
yeah,
what it
yeah,
means.
yeah. It's like words of chemistry, words of the.
Yeah, yeah.
That's.
Okay, so let's. Can I download this?
Yes, sir. Okay.
Okay, so for example, let's just do. Copy. Translate.
Oh, thank you very much. I know this. Is it
Okay.
always free?
Into. What's your
Farsi.
name? You said.
Persian. Dari. D-A-R-I. Enter.
Uh-huh. Oh.
I have to make an account.
You can get an upgrade and pay for an upgrade, but you don't have to pay for it.
Continue.
It got rid of it, okay. Translate.
To Persian and Persian.
To P,
Persian is
like that?
Persian.
I-N?
Persian. Yes. Modular
Is that,
Yeah.
you do that?
I will, thank you very
So,
much.
so over here, let's see. Select the whole thing,
Yeah. and,
copy, paste it,
I'm going to keep this and save it.
look like this. Let's do it. All right, here it's right here. And it's good.
Yeah.
And you want to save it the booklet part, and it's way down here.
Yeah, exactly.
You want to move it here?
Yeah, I think that will be super good. Yes.
Now it's right there, you just click on here.
Yeah, no, thank you very much. I didn't know this one. This is soft propino.
Then you can read it in your own language.
I will read then this and then put it here, so it gives me more sense. There was a, I will show you the last time. I don't want to keep you this time.
You're fine, you're
I
fine.
need to eat.
No, I'm okay.
This is my language. The teacher, one of my friends, explained to me and sent it to me. Oh, it's in the action.
Oh, good.
Yes.
Fine, now watch this. So here's the explain oxidation reduction reactions.
In Persian. Oxidation کاهش اختصار reduction. Now is what motivation. Wow, excellent. Thank you very much. I really appreciate it.
Ah, sorry, I didn't think about that before.
Yeah. Now it gave me the example.
Uh-huh,
It says,
yeah.
misal means example. یک نمونه کلاسیک واکنش دستور oxidation sodium electron از دست میده lose electron تبدیل میشه به oxidation افزایش میده. Thank you. Yeah.
Is that gonna be good?
Now I'm going to those stoichiometry and the last chapters. I will mold everything I believe and read and then see your example and based on this example, yeah. That's
There you
great.
go. Oh,
Who
that-
made this and is it rock.com? Is it? some-
No, it's just, yeah, I don't know for sure, I think it might be Elon Musk that made it.
Excellent. That's very lovely. So it gives me more sense once I'm reading English and reading here.
Yeah, and there's a whole lot of, yeah, all that.
I will read this. Thank you very much. I really
You can
appreciate
ask any question you want on there.
it. Like last exam, I didn't know a few English words, meaning, hey, I choose, I just say, let's go.
And don't go too fast anymore.
No,
Slow down.
next time I will say
You
this.
have like almost 2 hours. Take your time.
I will, next time I will sit slowly and I will think and I will, the next exam until you say I'm on, your time is over 10 minutes, I will. Either on Wednesday or Thursday morning I will go after class.
Tuesday?
Tuesday or you say that you have 10 days, huh?
You have till the 10th, which is Wednesday,
Which is Wednesday.
but we don't have class on Wednesday.
No, on Thursday we have class.
Sure, but
But I will see. I will
Okay.
not sit far back, but thank you very much. I will learn a lot of stuff now from this today.
good,
It
good.
helps me a lot. I think you need to eat because the other class.
No, you're fine.
those non-science classes, I have A, and like sometimes my brothers told me, you need to study something without science because you have this.